Please be aware that it is a legal and company requirement that the intended trainee complete this training. This requirement is taken seriously. This system contains a number of IT features to detect fraudulent activity. Welcome to this online job safety analysis training. This training is designed to help you understand the purpose of a job safety analysis, when to use it, where it fits into the risk management process, and how to create a good JSA. This training does not cover all situations or conditions and is not a comprehensive guide. Depending on the work that you do, there may be other training requirements you must comply with. This presentation does not replace these other training requirements for an individual's specific role. This training will take approximately 40 minutes to complete. If you leave the training before completion, you can log back into the system and it will automatically resume at the section you left. A job safety analysis is commonly referred to as a JSA. Depending on where you work, JSAs may also be referred to as the Job Handling Analysis or JHA, Job Safety and Environment Analysis or JSEA, Job Hazard Breakdown, Job or Task Risk Assessments and so on. In this presentation, we're going to use the term JSA. Whatever your company calls it, job safety analysis is an important part of a safety program for preventing work accidents. It's about systematically looking at each step of a specific job to identify, assess, and document hazards and safe work practices to help ensure that appropriate controls are in place so the job is done safely. The effectiveness of a JSA can vary greatly depending on the knowledge of the people completing it and the quality of the JSA process. This training aims to improve the quality and consistency of JSAs in your workplace. It's important that you understand it is not the JSA form that will keep people safe on the job, but rather the process you go through to develop the JSA. It's of little value to identify hazards and devise controls if important hazards are missed, if controls are not appropriate, if requirements are not communicated, or if the controls are not put in place and maintained. The process is much more important than the piece of paper that documents the process. A well-developed JSA used properly is a useful safety tool. However, a poor JSA may not only be ineffective in preventing injury, but can create an additional hazard, a false sense of safety. A poor JSA may give the impression that all appropriate controls have been put in place and the job is safe. Workers may relax, become less cautious, and fall into the trap of unidentified and uncontrolled hazards that are waiting for them. Some companies prefer to expand the analysis to cover other risks such as environmental, damage to equipment, lost production, and so on. These approaches may be known as Job Safety and Environment Analysis, JSEA, Total Job Analysis, or Job Analysis. In this presentation, we will use the terms job and task interchangeably. A JSA is one of several risk assessment tools that help to identify and control risks. A JSA is a basic and low-level risk assessment tool and sits above the individual informal risk assessment or risk awareness tools such as Take 5, Stop and Think, Break for Safety, and SLAM, and below more complex risk assessment tools such as RAC and formal risk assessments. Lower-level risk assessment tools such as JSAs are used for low-risk and low-complexity job tasks. As tasks become higher risk and more complex, higher-level risk assessment tools must be used. This means that if a task is too high risk or too complex, the JSA is not the appropriate tool, and you must use a higher-level tool and/or talk to your supervisor. In most organizations, a JSA is used to evaluate tasks in the following situations. Task is low risk and low in complexity. Task is well understood. Task is not routine, task has changed, or task is new. For example, people, equipment, or conditions have changed. Task is too high risk or too complex for individual informal risk awareness tools such as Take 5. An individual risk awareness tool, such as a Take 5, has been completed and it indicates that a JSA be completed. Or task has no written job procedure or standard work instructions such as safe work plan, safe work method statement, and so on. JSAs may also be used to help develop written job procedures, pre-start checks and such. However, JSAs used in this way should have a more complex method of risk scoring and should be developed by a suitably senior and qualified team and signed off at a more senior level. This presentation does not cover these higher level JSAs. Remember, don't use JSAs as the default primary tool to identify hazards and controls when the job has high risk or high complexity. A JSA may not be the right tool if the task has a long duration, for example, over one shift, involves multiple work teams, is unusual or involves interconnected mechanical items such as hydraulics, gears, pulleys, levers, motors, gearboxes, etc. Involves interacting systems such as electrical, mechanical or hydraulic systems, or is technically complex, or involves the use of new equipment, tools or chemicals. JSAs are not suitable for jobs defined too broadly, for example overhauling an engine, or too narrowly, for example positioning a car jack. And remember, a JSA is not a pre-start check or permit to work. A job hazard analysis should be conducted by a team familiar with the task. The team should include workers familiar with the job, workers who are going to do the job, and if applicable, supervisors or other relevant specialists. A team leader should be nominated who is responsible for ensuring that an appropriate JSA process is followed. The team leader should be competent in developing, facilitating and writing JSAs. The team leader does not necessarily have to be familiar with the task under analysis if the selected team members are. The team should involve those who are doing the job and not those who happen to be available at the time. By involving a team of people who are competent in the job and involved in the job, the likelihood of missing a step or hazard is decreased and the likelihood of efficient and effective controls increase. Workers who do the job regularly will have valuable job insights, such as unsafe shortcuts or ways to get around protective devices. If possible, all employees who will be involved in the job should contribute to the development of the JSA. This is an effective way of encouraging employees to participate in hazard identification and risk control. It also builds a culture of understanding and compliance with the rules. A JSA can be completed by a team with or without the participation of the supervisor, but the supervisor should review and approve the JSA. It is the supervisor's responsibility to make sure that the JSA team has the necessary resources to complete the JSA properly. This includes skills, people, sufficient time, hazard prompts, checklists, training, relevant records and documents. This section will explain how to fill out the JSA form. The objective of a JSA is to take a systematic look at a job to identify all significant hazards, put in place appropriate controls for each hazard, and determine if all hazards are adequately controlled. In other words, the objective of a JSA is to determine the safest way to do a job and decide if it is safe to continue. A JSA involves the following steps. Break the job down into its basic steps. Identify the hazards associated with each step. Identify controls to eliminate or mitigate each hazard. Determine if each hazard is adequately controlled by the combination of controls. Communicate the JSA to all stakeholders. And make sure controls are in place before the job starts and during the job. Be alert for changes and monitor the effectiveness of controls while you work. The basic JSA form has 4 key columns: In the left column, you list the sequences of basic steps of the job in the order in which they occur. The next column lists all hazards for each step. The next column lists the controls for each of the hazards to prevent accidents occurring, and the right column lists the person responsible for making sure that the control is put in place properly. Remember, there is no such thing as a generic JSA. All JSAs must be approached with vigilance, and it is not good enough to simply recycle a previously completed JSA without a thorough review and update. Once completed, the JSA should be checked during an inspection of the job site, task or equipment. This is important to ensure that all hazards have been identified, controlled and properly recorded, and that nothing has been missed. Fill in the first page of the JSA, which includes the name of the author, your department, site, and so on. It's important to list the names of all the JSA team members. List the people doing the job other than JSA team members. When the JSA has been completed, it should be reviewed and approved by the supervisor before the job starts. Fill in the resources that are needed for the job. Examples of resources that might be needed for a job are equipment, tools, materials or parts. PPE required, including specialised PPE, such as harnesses. Permits. Isolation equipment, such as tags, locks, etc. It may be necessary to add or to review the list of resources required while compiling the JSA, as not all resource requirements may be known at the outset. For example, if we were doing a JSA on changing a car tyre, some equipment we might need includes wheel chocks, spare tyre, wheel spanner, car jack, high visibility vests, safety gloves, and row triangles. The first stage of the JSA process is to define the job which is to be analysed. Where does it start and where does it stop? This is called defining the job scope. Break the job up into a list of small steps in the order in which they occur. Enter each step in a separate row in this column. Clearly describe each step in a few words, 5 or less. Describe what is to be done rather than how it's done. Each step should be started with a verb, such as do, remove, open, or fix. Each step should be part of the operation necessary to advance the work. It's important not to make the steps too general, which may result in hazards being missed, or too detailed, which may result in there being too many steps. A good rule of thumb is to describe the job in fewer than 10 steps. Having too many steps may be a sign that the defined job is too broad and may need to be broken into parts for JSA, or steps may need to be combined, or the job may be too complex for JSA and may require a higher level risk assessment tool. You must also keep the steps in their correct order. Steps that are out of order may miss potential hazards, introduce hazards that don't exist, or confuse JSA users. Using our example job of changing a car tyre, we might break up the job into 5 steps. Prepare to change wheel. Change the wheel. Fit new wheel and finger tighten wheel nuts. Lower vehicle and tighten wheel nuts. Pack up and stow gear and wheel. The hazard identification stage represents the heart of the JSA process. Identify all the hazards associated with each step of the task and enter them into the form. Clearly describe each hazard in a few words, 5 or less. The most important part of this stage is to not miss any hazards. Identifying all significant hazards is a difficult thing to do. A large part of the JSA development process is designed to prevent significant hazards being missed. A hazard is anything that has the potential to cause injury, harm, or damage. Remember, there is a difference between hazards and consequences. For example, slips, trips and falls are often written in as hazards, but these are only the consequences of a hazard. We need to know what the hazards are or the causes are so we can control them. A hazard such as oil on the floor can cause a slip. This hazard may be written as oil on floor causes slip. The hazard identification process must consider the actual work environment where the job is to be conducted. This normally requires an inspection of the job site, task or equipment. Human hazards, potentially unsafe acts, behaviours and oversights by personnel. Can equipment be used incorrectly? Can workers take shortcuts? Can workers deviate from the correct job procedure and so on? Energy sources. The energy concept is useful for understanding safety and health hazards. Physical damage to people can only occur due to energy. Using prompts to assist identification such as people, environment, equipment, procedures and organisations. Or prompts in the form of questions. Unplanned or secondary knock-on effects of actions, behaviours or conditions at the job site. Hidden hazards that are not obvious. Developing hazards, hazards that can emerge as a result of work activity in each step and changes in the environment. Hazards that have low initial consequence, but over time the consequence may change or increase. For example, gas build-up, hydraulic oil on turbo, fuel line failure, etc. Job observation by experienced personnel on the job site. Previous incidents and accidents, and other lessons learnt information relating to similar tasks. The hazard identification process must also consider any changes to the work environment or tasks while the job is being conducted, and the effects when the job is handed on to the next shift. Using our example job of changing a car tyre, we will identify possible hazards associated with the first step of prepare to change the wheel. Possible hazards include road traffic interaction and unsuitable ground conditions. At this stage of the process, it's important to consider if the task can be redesigned to be safer. Can a less hazardous way be found to do the task, or can an engineering revision take place to make the job or work area safer? Can the people, equipment, environment or conditions be changed? Is there a better way to do the job? A note of caution. If the job changes make the task more difficult, longer, more inconvenient or uncomfortable, then employees may take risks or shortcuts to avoid these procedures. Caution must be exercised when changing job procedure to make sure it is practical and does not introduce human hazards or any other unintended consequences or hazards. It's also the right time to consider if the necessity of doing the job or frequency of doing the job can be reduced. Often maintenance jobs that require frequent servicing or repair of equipment are hazardous. To reduce the necessity of doing these jobs, ask what can be done to eliminate the cause or condition that makes excessive repair or service necessary. At this stage of the JSA, the team must determine and agree on appropriate controls to reduce the risk associated with each hazard to acceptable levels. List the controls for each hazard into the form. Clearly describe each control in a few words, 5 or less. The hierarchy of controls should be used to determine the most effective controls for the hazard. When determining appropriate controls, consider the following. All significant hazards must have at least one control measure. The reliability and effectiveness of controls must be reviewed to ensure hazards are appropriately controlled. A hazard may have several individual controls that are only effective as a cluster of controls. Determine if hazards are adequately controlled by looking at the combination of controls. All controls documented in the JSA must be in place at all times while the job is being performed. All controls must be practical, realistic and effective in controlling the hazards. The blanket use of referring to procedures or other documents as a control in any job step is not effective and could indicate that the JSA has not been thoroughly completed. However, it is appropriate to refer to procedures or other documents as part of a control. Check to see that new hazards have not been created by the new controls. For instance, a control for a dusty road causing limited visibility to haul trucks may be a water truck. But if too much water is applied to the road, it can introduce the hazard of a slippery road. This hazard now needs to be controlled. Communicating the hazards and controls to the personnel performing the job is essential. Remember, if no reasonable or practical controls can be identified to reduce the risk to acceptable levels, then the task must not be completed. Notify your supervisor to discuss. Higher level risk assessment tools or job redesign may be needed. Using our example job of changing a car tyre, we will identify controls for the first identified hazard, road traffic interaction. Ensure that there's enough room on the shoulder of the road to change a wheel. Move to a better, safer location if required. Turn on hazard lights. Warning triangles placed at 50 metres and 75 metres along the oncoming traffic lane. And personnel to wear high visibility vest. Each control should have a person identified as responsible for ensuring the control is in place. That is to say, implementing the control and maintaining the control while the job is in progress. All JSAs require sign-off by the JSA team to indicate that they're in agreement with the content of the JSA, will comply with the JSA, and that all hazards are adequately controlled. Sign-off by the team leader also indicates that an inspection of the job site, task or equipment has taken place to check that the JSA is complete and nothing has been missed. All employees involved in the job who are not in the JSA team should sign off on the JSA before starting work. Sign-off indicates they have read, understood and will comply with the document and that they agree that all hazards are adequately controlled. All employees have a duty of care to refuse unsafe work. A supervisor is required to approve the JSA by signing it off. Sign-off indicates that the supervisor has reviewed the JSA and is satisfied that the JSA has been completed appropriately. An appropriate process has been followed to identify all hazards, and that all hazards are adequately controlled. Individuals should never sign the JSA without reading it, understanding it, and agreeing that the document has been completed appropriately and that all hazards are adequately controlled. Because that is what you're agreeing to by signing the document. JSAs are important legal documents and are often used in incident investigations, disputes, and court cases. Once the task begins, it's important to ensure that controls remain in place for the duration and to monitor the worksite for any change in conditions that might alter the hazards and controls in place. If there is any concern, stop the work, reassess the hazards and controls. If necessary, replan, reassess the job and redo the JSA. A person must be able to demonstrate the skill and knowledge required to carry out the JSA to an acceptable standard. To satisfy the requirements of JSA competency, the individual must undergo initial training on JSAs through formal training courses and informal on-the-job instruction to understand the value, importance, context, application, and the basic process of conducting JSAs. The training module must include the hazard identification process and undergo regular refresher training on JSAs. Supervisors and JSA team leaders may require more advanced training than other JSA team members. Ideally, the JSA should be reviewed by the work team at the end of the job to ensure it achieved a safe job outcome. It's also important to make note of any lessons learnt. The JSA should be modified accordingly to document this new information and contribute to continually improving safety. To ensure hazards are properly captured and addressed, JSAs should only be valid for the job at hand and must not simply be recycled from job to job. The JSA needs to be fully reviewed and updated before each use. Don't just reuse JSAs. But previous JSAs can be used as a starting point for the new JSA. As well as its primary purpose of identifying and controlling hazards, a JSA can be useful in helping develop task training, task standardization and procedures, checklists for safety inspections, topics for safety discussions, audits and incident investigation. All JSAs must be retained for recording, tracking and auditing purposes. JSAs are an important part of any organisation's health and safety management system for the prevention of work-related accidents, injuries and illnesses. The JSA technique is a good way of getting employees to take part in assessing safety and reducing accidents. Through JSA, workers can play an important part in setting up and maintaining safe work procedures. Everybody in the workforce should be involved in creating the JSAs. The more minds, the more years of experience applied to analysing the hazards in a job, the more successful the JSA team will be in identifying hazards and deciding on suitable and effective controls. If you are tasked with producing a JSA or signing off on a JSA and you're unsure of the process or the outcomes of the JSA, then you should talk to your supervisor or safety professional before signing the document and before starting the task. It is essential that you understand all the information outlined in this presentation. If you do not fully understand the presentation, or if you have any other questions or concerns, you are required to contact your supervisor or host for clarification.